All right, now let's go through them. We've talked about these three. Let's go through the three types of structural isomers, okay? The structural isomerism. Number one is functional group isomerism. We said in functional group isomerism, what is different? The functional group. So in functional group isomerism, there are different functional groups present, okay? If it's called functional group isomerism, then the functional groups are the ones that are changing. So but the compounds will be having the same molecular formula. So these are compounds. It's a type of structural isomerism where the compounds have the same molecular formula but different functional groups present. And let's see some families that can do that. There are families that can do that, okay? Some homologous series where you can have functional group isomerism, okay? In other words, there are certain families where you will have the same molecular formula but different functional groups. And that is alkenes and cycloalkanes. So that means if for alkenes and cycloalkanes, they'll be the same. Like if I have an alkene with 4 carbons, it will be C4H8. If I have a cycloalkane with 4 carbons, its molecular formula is still C4H8. Okay? So alkenes and alkanes will always have the same molecular formula. But we know that their structures will be different because they are from different functional groups. Alcohols and ethers. I know you haven't learned ethers. I'll give you an example, but these guys are also very much the same. They will have the same molecular formula. So alcohols and ethers exhibit functional group isomerism. Okay? These are functional group isomers of each other. And then you have aldehydes and ketones. Aldehydes and ketones, when they ask you for functional group isomerism, aldehyde and a ketone, these will have the same molecular formula, but they will have different structural formulas. Let's draw these things. Let's put an example. Let's put alkene. We've already seen alkene versus cycloalkane, but I'll do one more, okay? Alkene versus cycloalkane. Okay? These guys will always have the same molecular formula. So I'll put the one with 4, C4H8. So let's say EG, C4H8. Both of them will use C4H8. For the alkene, I'll just use I'll use the displayed formula, but yeah, 2D, the 2D one. So it's going to be 1, 2, 3, then 4, right? And I can have it here, okay? I'm doing functional group isomerism. So here I'll have it like this. Here I'll have it like this. Then here I can have an H here, so it's going to be like this. I just know that carbon should have 4 bonds. That's what I use to guide me, okay? Carbon should always have 4 bonds. So this guy has 2. He's going to have 1 more, 2 like this. This is your alkene, and we can call this butene, okay? It's but1-ene, right? If you want to call it, or 1-butene or but1-ene. Then it is going to be, the cycloalkane is cyclobutane. So let's have it. It is like a rectangle like this, and you can have like this. This is going to be your hydrogens. This is going to be your hydrogens. And if you count, you're going to have exactly 4 carbons and 8 hydrogen. So this is still C4H8. This is also C4H8, but1-ene and cyclobutane. Okay? And we can have alcohol and ether. So for alcohol versus ether, this is very nice because let's just put propanol. So alcohol, let's say alcohol versus ether. Let's put for alcohol versus ether. They will have the same. So let's put the one where you have what should we put for our alcohol? Yes, let's do the one with 3. So C3H8O. Okay, both of them will be C3H8O. So now what would it be? For my alcohol, it would be propanol. I can just put it like this. Then I can put my OH at the end. Remember, here we are talking about functional group isomerism, where the functional groups are going to be. We have 2 different guys. We're going to have 2 different. For them to be called isomers, there must be 2, right? So we're going to have 2 different things. So here we have our OH. You can have an H and an H again. So this is going to be something like this. This is going to be your alcohol, and this is going to be versus. If I now put my ether with 3, is going to be, the difference between an ether and ester is that ester is C double bond O then O. Ester doesn't have, it only has 1 O like this. So it's CO, then you have a C like this. So it's going to be like this. then it's going to be like this. So this is going to be my alcohol versus my ether. This is going to be my propanol, okay? Propanol, okay? Or I can put propan 1O, okay? And then here it's on my propanol. Then this is going to be called, you start by this one on the left, it's going to be meth. So it will be called methoxy. We call it methoxy. Then since there are two here, it's ethane, okay? So this is going to be my ether, and here is going to be my alcohol, right? And they are functional group isomers of each other, these two. Now let's put the last one. The last one I'm going to put is going to be aldehyde versus ketone. So I will have my aldehyde versus ketone, okay? And I'll put the one with 3, so it'll be C3H6O, okay, for both. And for my aldehyde, I could have it just like this, CC, then C, okay? And I know that it does a double bond or then an H here. Then the other one is like this. My aldehyde, I know that my double bond is at the very end. So this is going to be this is my aldehyde, and it will be proper now, my aldehyde. And for my ketone, it is going to be the same. So it'll be C, 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 like this. But then the double bond will never be at the end. It will be inside like this. Then I will have my hydrogens like this. And if you see, both of them will be C3H6 and an O, both of them. And this is going to be propanon, okay? This is going to be propanon, my ketone. And these two are going to be functional group isomers of each other. So functional group isomerism, what changes? There will be different functional groups present. So the functional groups are the ones that are different. So you have the same molecular formula, but different functional groups present. That is going to be it. And we have seen the guys that exhibit functional group isomerism. It aldehydes and alkenes and cycloalkanes, alcohols and ethers, which we hadn't done, but I've shown you the ether. Then aldehydes and ketones. Okay, these ones. And you would be done. This is for functional group isomerism. Now let's go look at the other two, the position isomerism, which already tells you that it's the position of the functional group which changes, and chain isomerism, where the chain changes. So we go see them in the next video. Goodbye for now.